Um, well, great. Let's go ahead and jump straight into it. I am super excited for this topic. My name is James. I was a security engineer for about 10 years, and since then created Latio as a way to help practitioners find the best security tools and what they actually do and understand what's going on. So I'm super excited for this webinar for us to be diving into AI workloads because there is so much hype and confusion around what these are and what they mean that I think it is a great opportunity to bring some clarity to it. But Brett, how about you?
Yeah, I mean, I think as we started to think through some of the runtime level information that we can see and some of the other kind of attack path information we can see, we really started thinking about AI as agents. And a lot of the questions we were getting from our customers were, can you help me just discover the AI agents that exist within my environment? But I think as we kind of looked at it, there's a lot of different types of AI workloads. And I think that's what we're going to get into today, which will be more exciting to kind of talk through. But not everything that is AI necessarily looks like AI. A lot of services kind of look like other services, and so there's certain ways that you have to look at them. But there's also just a lot of different ways that you can leverage AI within any enterprise environment. So looking forward to it.
Yep, sounds good. So let's hop into what makes AI workloads different from traditional ones. And as what you said, there is a sense in which AI workloads are very similar to traditional ones. Like most of the time, they are running in containers and they are running APIs that are inputs and outputs. And so it's not as though this is some wildly, vastly different terrain, but there are some real security implications around what is different. And the most important one is this first one where decisions are probabilistic based on the prompt, based on the framing, based on the scaffolding or the skills, but they're not deterministic inputs and outputs. And so to me, that creates a lot of renewed interest in the application layer because that's where these decisions are going to be happening. That's trying to understand what actions an agent is going to take is not the same as every time the user clicks this button, this corresponding API call is going to fire off, which is going to do this exact thing. But rather, there's a range of possibilities that we have to be accounting for and understanding what's there. But yeah, I'm curious what you think about just this high level, what makes the AI workloads different piece.
Yeah, no, I think well, you definitely nailed the first part of it, and that is that in AI you're not going to get the same answer every time necessarily, but what that inherently does is it starts to create a kind of a trust envelope where in a lot of cases folks are looking at the AI agent and they put a lot more trust in the AI agent and the decision that it's making, or they put more trust in some of the tools that may be used downstream, be it a RAG or be it an MCP. And that obviously creates a lot more opportunity for, the attack surface to really expand. And I think that's kind of the biggest thing that we're looking at is that not everyone fully understands the AI end to end. And I certainly don't understand it always myself, but it certainly creates a lot more opportunities for there to be potential, again, attack surface or different types of attacks that can be entered because there's so much trust put back in on the AI components within an architecture.
Yeah, and I think this goes in really nicely to we're going to be talking about three different types of architectural models at a high level. And what's challenging even about these is everyone is running AI a little bit differently in the first place, to where like we're going to be talking about these high level buckets of types of AI architectures. And I would argue that your risk increases as you move down the chain here towards more agentic architectures. But people are using there's all sorts of nuances within this as far as what orchestration tools people are using, whether it's LangChain type stuff or it's Crew AI, or if they're bringing in some of their own custom models, or if they're going through Bedrock, or if they're going direct to the API providers. There's a lot of different ways that these tools can get combined that also change the risk profile. But let's go ahead and start with this is probably the most basic type of interaction. When we think of early AI tools, this is most of what we're talking about, where it's just this direct model call where a user is saying a prompt and you're just adding a prompt in front of that saying, you are a car sales assistant and your job is to give the user relevant data when they ask about a specific car model. And then it's just getting passed straight to the back end and then responded to the user. This is how most, like when people affectionately call tools ChatGPT wrappers, this is usually what they have in mind. It's a lot of the first generation of tools that's about trying to tailor OpenAI or Anthropic's models to specific use cases. Um, but yeah, is there any before we talk about the risks with this? Anything you want to add, Brett, about this sort of architecture and how common it is and what you're seeing?
No, I mean, I think this is the most common architecture, at least in the early days of AI. And again, we can talk about the risk and other things, but it's, as you say, it's kind of the safest. It really depends on what's in the model to a large degree, and you can put more guardrails around this, I think, than in other areas. But again, it's still not 100% fail safe as well.
Yeah, this is where I think the major risks that come out of this model because there's no like proprietary data lookup happening. It's more about trying to track the model's intent. And so if you say are using like a car sales AI tool, you obviously want it to recommend your car and not the competitor's cars. And so there's like guardrails you're trying to put on around like specifically what the recommendations of the chatbot are. And then there's a lot of like data loss prevention type lookups that are happening where people are trying to prevent like what happens if someone puts social security numbers in here or what happens if someone puts proprietary company data in here. We want to sort of flag it and make sure that it's not being used as training data. And at this point, OpenAI and Anthropic have a lot of controls around should this data be reused for training or not. But to me, this is a pretty low risk architecture. But do you agree with that?
Yeah, I mean, I think you hit it. It's prompt injection. There's some sensitive data that may exist within, the model that may leak at some point as you kind of go through it. I think the challenges are, and this is where, we try to, stress that, runtime allows us to do things like detecting the data exposure in real time, monitoring for the outbound connections for any kind of exfil that occur, and really just monitor for any kind of abnormal tool usage. You can argue that some of those can be done with proxies or with other tool sets, but I think the most important one would be if there is any kind of exfiltration or outbound connection that's created. That's the level of detail that you would see at a runtime situation as well.
Yeah, that's actually a great point. The thing that I didn't call out is developers can sometimes get creative, let's say, with like how they're preempting these prompts, where they could be taking user input from elsewhere in the system and using that as part of the system prompt in a way that would essentially be a lot like this next architecture, but without like officially doing it. But let's go ahead and hop into RAG systems. And typically these involve creating some sort of fine-tuned data layer that you are having the application fetch additional data into. The most common way to do that is with some sort of vector database that you've trained based on your own in-house data to try to create some of your own customized associations based on your specific industry. And so this is common in larger enterprises that have a very specific set of data that they're trying to bring in, like their own insurance policies or their own medical data or things like that. But there's a lot of here the biggest risk comes into if an attacker is able to taint that data in the first place. They can do anything from classical prompt injection, but via the what the RAG is pulling in, or they can do really hard to detect data poisoning where there's like a slight preference in specific scenarios where the system will recommend one thing or another, or could influence a user to do something that's unintended. And so there are different security concerns here, and they tend to interact more from like a supply chain perspective into the underlying database um, layer. But from a usability standpoint, I typically see this the most in like large regulated industries that are trying to give AI optimal usage of their proprietary data that have a lot of like valuable IP in those policies and things. But I'm curious both in what you see from like a adoption standpoint, but then also those sort of risks that come out of these sorts of architectures.
Yeah, I mean, I would say fintech, as you said, healthcare tend to be the biggest industries, at least that we deal with, where the RAG model is kind of pervasive. And as you say, it's a lot of the proprietary information, but it's going to be things like the policy documents, any kind of capabilities. And we'll walk through one example later on where approval policies, things of that nature, tend to be things that can be embedded within these vector databases. Again, mostly, it comes down to the trust layer again. How much are you trusting the content that's actually in there? How are you able to kind of model and kind of monitor for any kind of anomalous type of behaviors? are we seeing anything else that's kind of injecting patterns into those responses that may not be the original intent of what you were looking for out of the RAG system in the first place. So definitely,
Again, I we don't have a separate architecture for it, but I would also consider using like open source third party models or data sets as very similar
yeah.
sort of systems to this, where yeah, you're trying to ultimately trust an untrusted third party system. Um, but yeah, let's go into what's becoming, the AI buzzword of the year is agentic. And really, I love an AI agent is just a LLM in a loop with MCP slash API tools. And it just keeps trying to do the thing until it is successful at it with its own test. And so, really, I think there's a lot of thought about agents that sort of gets detached from their underlying architecture, where it's very easy to conceive of these things as like ephemeral moving pieces that sort of make their own decisions in pieces, which part of that is true, but from a capabilities standpoint, I think there's two things that make these systems fundamentally large improvements over prior architectures. The first is the ability to plan large changes and then hand those off to sub agents to go and run smaller tasks to really speed up both the complexity of what's possible and the time in which it can be delivered, the final result. And then the second piece to that is access to some kind of underlying compute. Because when you offer that up to an agent, it can do a lot of additional data fetching, data stitching. You can give it like MCP tools are really just function calls, and you can attach static code scripts as tools for an agent to call. And so, really, you're just it's like giving a live developer access to this agent to go and make all sorts of changes. And in what we've been talking about from like a risk escalation standpoint, this is where, in my opinion, we've gone from very low risk to, as soon as we do agentic architectures, extremely high risk. And the earlier architectures we talked about are just low risk to me because it's a lot of like reflecting back to a user what they're saying, or we're trying to protect the user from like if they gave us a social security number, how do we mask it in our response to them? But it's not like we're fetching additional users social security numbers or have some large data leak opportunity. But here, as soon as we open up the possibilities of tools and the underlying compute, we suddenly have a huge potential blast radius to worry about that covers everything from permissioning to what tools it has access to the OAuth grants to other third-party services. And really, we're allowing pretty unfettered access in a lot of cases to all these additional tools. And I think this is made worse by the fact that a lot of people's cloud environments, have this dream of least privilege that's never quite achieved in reality. And we're actually very generous in our permissions, whether it's like running containers as root, whether it's having admin Kubernetes credentials for most of our services, whether it's Terraform roles with privileged access to everything in our AWS. We just want these things to work. And so they tend to be highly permissioned and they have a high degree of autonomy to go and complete things. And so here is where, we'll be showing on the next slide how most solutions work. But this is why I think with agentic architectures, runtime becomes the most important piece of security. But also, I think that we've increased risk dramatically when we move to these architectures.
Yeah, 100%. And I was going to call it privilege escalation, but to your point, sometimes the privileges already exist, as you say, in certain levels of the architecture. So it's tool abuse, it's privilege escalation, it's, there's still data exfiltration, and then there's the infrastructure itself and how you can manipulate that. So there's just a lot of different moving parts here. And again, because it's agentic, it doesn't always look the same. So building the pattern, building kind of the deterministic approach no longer works in this type of scenario. So from a runtime perspective, it's actually really putting together the workflow end to end, tracking kind of the API execution chains, kind of looking for identity usage, detecting any kind of outbound data movements, and ultimately, we talk about an attack path, we talk about a blast radius. It really is that level of visibility and understanding, who calls who, and historically who did call who, and what was being exchanged as part of those operations that you were looking for as well. So definitely agree that runtime, it fits in the other models, but it's certainly, in this level, it's much more complex. just due to the live and real interactions that are going on back and forth.
Yeah, so let's talk about the way most security tools work here and sort of like the pros and cons of the different approaches. The first is the classical agentless scanning that really took off in the cloud. And this is a great approach for getting basic visibility because essentially what these tools are doing is just looking at all of the contents on the hard drive, finding packages that are loaded. So like if you're loading the OpenAI SDK, there's a strong chance that, hey, that's a AI workload. Or if you're loading a crew SDK, same thing. And so really it's great for getting visibility into the configuration of the asset in general, but it can't really tell you anything that you're doing, right? And the part that makes this interaction so risky is this app service to the underlying compute architecture, and without some sort of runtime interrogation happening there, you can't really get visibility into how the AI is making decisions, what tools is it calling, what is it executing in your environment. And so agentless is once again a great like basic visibility option to let you know like what your developers are using, but it doesn't really tell you what it's doing. And the second option is what most AI security, quote unquote, like specialist providers are doing, which is some sort of network proxy approach, either a outbound proxy or a reverse proxy, to try to get visibility into what those API calls are actually doing. And this is a great way to see what you have access to when you see that is all of the inbound requests that are made from a user. So you can look for things like prompt injection. You can try to, a lot of providers will use like small language models to try to gauge the intent of a user before the query executes and then block it at the network layer to try to get that basic visibility. And then basically, those tools can also see the output, right? So they can look for like sensitive data if a service is going outbound, or it can look for if it looks like a prompt injection has been intentional or has been successful rather. Um, but really, what that proxy approach doesn't see is the actual execution chain or the chain of thought of the agent itself. And so it can't actually see like what tools were called, but it can't see like why they were called, what input was given to them, what outputs were given. So just to use an example, right? Like let's continue with that car sales bot example. Let's say we made it an agentic car sales bot and it was able to actually go and look up the car in a database and figure out what was done. The thing you would want to see during a security incident is okay, what was actually executed, like what SQL was executed to try to generate that command. And so, like, that's the critical piece of infrastructure that's missed by a lot of tools because they're just monitoring the inputs and outputs from the system with the proxy, but don't get the full decision context of the agent. But is there anything you want to add on these pieces?
No, I mean, even as you talked about with the reverse proxy, it also has to be installed. So even in your simple model that's above, the proxy has to be installed in between each one of those nodes there. Otherwise, it's only seeing, bits and pieces of the information. And so when you talk about the request and we talk about the responses, it does limit quite a bit what you can actually see and really what's going on inside each of those nodes as well. So, agree.
No, that's a great point. And there's all sorts of extra issues that developers hate dealing with, whether it's now you've got this upstream dependency that you don't control, you might have latency get introduced as a result. The
Exactly.
SDK might not support all of the features you want to use from like the AI provider. So there's a lot of potential headaches with the proxy approach just to get that visibility. Um, yeah, and this goes along the lines of how the risk increases over time. And so in my mind, like I basically treat most ChatGPT wrapper style of integrations, those first ones of traditional apps, as really being like forms of DLP, where you're just looking for sensitive data that's not supposed to be exposed, that may be exposed as part of a request, or if like an employee is uploading documents you don't want them to upload to an AI agent. It's these very basic sort of detections as the main risk. And then as you move into sort of a RAG architecture, you get more into those supply chain risks, where you're looking more for the data poisoning and if you can trust the models that you're using. But really, it's this final prompt injection to a privilege escalation that the risk becomes uh, pretty escalated. So what's so funny to me about AI security is it's like the risk in my mind is either almost zero or it's extremely catastrophic. And it really just like you change that flip happens in a way that can be almost invisible to a security team because you might have this like very low risk system prompt that all of a sudden a developer wires up like a CLI MCP tool access, and all of a sudden your risk has just exploded off the charts. So it can be really hard for security teams to figure out like where in this journey are we, like how risky is our AI application.
Yep, absolutely. And I think you nailed it as it relates to just, the evolving risk as you get down it. But as you also say, we saw a lot of the traditional kind of app in the early days. With everything that's going on out there now, we're seeing the AI workload or the agentic models really start to, that's the new model. That's the big thing that's going on. And again, that's the one that most people have the least amount of information and the least visibility to actually what's going on behind the covers. So,
Yeah, I think this slide does a great job breaking down like what is actually happening behind the covers there, where um, the old model really is just like prompt to API call to response. And it's really just like a three-part piece. But now as you have all of these, like if you throw even the fact that this whole agentic timeline that's up top could also just be part of like an orchestrator agent's decision making, which is then subsequently calling other agents to run this whole workflow for themselves. The attack surface once again, or the potential like the amount of data you need to determine if something even went wrong in the first place has exploded to where you're trying to correlate all of these requests together and determine if what's happening is intended or not.
yep. I agree. And I think the last sentence that's on there basically says, if you don't see the full chain from the decision to the execution, then you have very little visibility to what's actually going on under the covers. It doesn't mean that you don't have, let's say, posture management for the bits and pieces. It doesn't mean that you don't have certain detections that are out there, but the aperture has to be kind of widened quite a bit in certain circumstances, just because there's so much differentiation between what the agent may do under one scenario versus what it may do under another scenario, or what the downstream implications are going to be as well. So,
Yeah, and I think it requires like seeing the value in this requires a shift from thinking in terms of like have we been prompt injected to like a security incident happened. Do I have the data to even know what's happened? Because that sort of proxy approach will tell you with like medium confidence in terms of it's a lot like the old WAF rules where it's like there's ways to bypass guardrails. Maybe they work, maybe they don't. But if they do work and someone does get in, do you have the tools you need to even figure out the scope of what happened, how it happened, is it reproducible, to try to actually investigate and figure out the scope? But now, Brett, I'll go ahead and turn it over to you to show an example of what this stuff looks like.
yeah, and we're going to kind of try to keep it, relatively real, but we'll also try to keep it, simple enough that we can understand it as we work through. So the examples, we have multiple, but the examples that I will show will really kind of line up with the three scenarios that we talked about in today's session. I'm not going to go through the whole platform as it exists. What I will do is just say that, part of what we're doing from a posture management or a runtime kind of CNAP perspective is that we're constantly discovering and identifying all the network resources, platform compute storage, and application resources. We're also collecting anything we see that are security events. We convert those to incidents, and then we call out the vulnerabilities, misconfigs, and sensitive data. So what you end up with is, you've got a lot of information, and I am only going through this particular piece just to say that, all the pieces and the parts of the AI components actually already exist within your cloud architecture. They tend to just fall into either an application component, or they'll fall into a compute component because, again, your cloud architecture is typically supporting a large percentage of what you're doing in your AI environment. From a security monitoring perspective, obviously there are going to be certain events, things that are suspicious or known malicious, and you want to be able to take those components, you want to correlate them back to the actual incidents. And then, like I said, you're going to call out the vulnerabilities, misconfigs, sensitive data. I went through that again only to say that, the aha moment for us was to really look at, hey, these AI security workloads are really just, individual components that are made up of the overall cloud architecture that we talked about. In most cases, they're considered to be applications that have APIs. They're running on compute. They, are interacting with certain storage or, databases and things of that nature. So really what we tried to do is put together views that basically said, hey, there's a lot of different interaction patterns that we've talked about here. There's kind of the standard direct model that we talked about to an LLM. We'll capture the workload, the model name, kind of what the work model provider is. We produced a RAG pipeline kind of example here as well. We produced more of an agentic model, but as you can see, there's a lot of different types of interaction patterns. And it's really understanding what each of these interaction patterns look like, what the relationships are between the various steps that you go through from an AI perspective that really help you understand, what the risk is, and if you've actually had either potential malicious data, or if you've got certain, vulnerabilities that you need to address. So I'm going to jump into each of these. We'll start really with this first example, which was the simple example that James talked about, the LLM. In this particular case, we know the model, we know the server that we're actually going against. We have a little component, which is business impact. That just basically tells us if this is compromised, what it would look like. But it really gets down to starting to show really the workload path itself. And in this case, what you're looking at is the employee is actually interacting with an LLM gateway. That LLM gateway is supposed to be responsible for some of the kind of guardrails that we've talked about. And then it's interacting directly with, in this case, an Azure OpenAI type of scenario. So we paint the generic workload view kind of in this format, and then we start to call out what we saw that was actually suspicious, malicious, or potentially attack level information that we saw. This example would be one where employee is doing what they're supposed to do. They're trying to take a confidential email, and they're going to run it through the email summarizer. That's going to help, basically take that information, put it in a format that they can actually use as part of the rest of their workflow that they're looking to go do. But the gates were kind of missed in this particular, and I got to get this out of the way here, in this particular attack, because what's happened here is there's been an attacker crafted email that basically says, hey, ignore the instructions that are being represented by the LLM and actually go and summarize the data, which results basically in it bringing back additional information. And then they used basically an additional tool execution to take the full confidential set of information and actually try to exfiltrate that information here, as you can see, to this fictitious paste.example.io website here. So what you end up with is kind of the details here around the chat called with system prompt override pattern. That would have been, the first thing that was detected for it. And then post that, you would actually see sensitive data disclosure in the outbound transaction as it was flowing out as well. So
I
this,
think that
yeah, go ahead.
there's two things I want to add here. Like the first is I'm shocked at the number of enterprises I've talked to where like they create their own agent builder sort of concept for employees to use, and they're deploying like tools just like this in production, where it's trying to have teams like a customer success team summarizes all their emails and calendar events and then uses it to update Salesforce for them or something. And it's just highly susceptible to prompt injection of various types. But then you can see the key moment here to where traditional runtime security that a lot of teams have overlooked in the cloud becomes like the pivotal piece where it's just that egress monitoring to a known bad DNS or IP is the thing that can trigger off exactly like not only do we know there was a prompt injection attempt because sometimes it's ignore previous instructions, but it could be Unicode injection, it could be all sorts of like really complicated prompt injection things that you might miss, but the thing you won't miss is the exfiltration to the attacker controlled server. So yeah, I think it's great to it really shows how traditional runtime monitoring is just essential for detecting like the actual attack moment.
Yeah, 100%. And again, I'm going to keep harping back to this concept, which is, a lot of this information, as we said, it's being detected at the runtime level. So in this view, you get the security view. It actually will take you back to the security events and even to the inventory components that I kind of highlighted at the beginning of this conversation. But these are a little bit out of order, I noticed, as I was looking at them for some reason. But it goes through shows you the details of what actually occurred. And then, as I said, if you want to go to the specific events or to the actual incidents, then you would have the visibility to go all the way back and see it at a very fine grain. This might be something that is only picked up at the runtime level. And then you've got the additional details so that you can run through the runtime context, getting all the way down to things like the network content, all the way down if you needed to the process call and the stack trace information that was delivered for that as well. So again, there's a lot of detail that's kind of buried under the covers. A lot of this is available for just normal security event monitoring and then incident correlation. The key here is you're able to, in some cases, very easily, but in other cases, based on the patterns or the behaviors, determine that it's actually an AI workload behind the scenes. And you really want to be able to pull that full attack scenario from end to end back together as you look at it as well. So good. I could spend a lot more time on this particular one, even though it's easy, just to kind of get the concepts across. But I want to jump forward to kind of the other two models just to give that level of visibility as well. So we talked about a RAG example or RAG pipeline type of an example as well. So for this particular one, you can kind of see here, it's a RAG pipeline that's running. The standard workload path for this one would be the approver basically sends, this one is a case where it's a financial system and they're basically asking, to get approval for a wire transaction that's going to be passed through the system. In this case, there's a retriever, which goes in and gets the policy information. So we talked about that earlier in this conversation. Gets the policy that basically says, at what point does a human have to interact before I can just approve this level of wire transaction? And then basically it runs it through the model to actually take the actions that it's looking for. In this particular example, what you see is that there was malicious content that was injected actually into the RAG database itself that basically had the model basically say, ignore any other instructions and just pass the approval all the way through. So in this case, you'll see that the retriever actually pulled from a different database source and actually retrieved a different policy execution for what it was supposed to do with this information. It then passes that information, which is trusted by the actual model itself. And then on the back end of this, what you end up with is now that we've got the information, the model actually pre-approved sending this information on through it. So you had a retrieval path, you had a suspicious kind of response pattern in terms of the prompt injection, but that prompt injection came from retrieving the document from the RAG pattern itself. And then once it saw that additional information, that then instructed it to do kind of a DAN attack or a do another activity, which resulted in a attempted exfiltration attempt as well. So any questions on that one? I guess, James, you're the only one that can ask questions right now.
No, we got a great question about the last one that we'll go back to.
Okay.
But yeah, I mean, I think this gets at the complexity of these sort of RAG attacks, which makes them, for your average business, I think it's less likely that you get into this thing. But as we lean more and more into like those automated, like the example is a great one of this is like the use case where both an attacker would be motivated enough to do this and the business is motivated enough to build this sort of like approval pipeline to deal with the scope of requests they're getting. And yeah, I mean, it's a great example. It goes back to that need to see the connections that the workload is making to other resources within the cloud environment and not just this like ingress egress, did the prompt injection work thing. Because it needs to see like that there's an anomaly in how the retriever is working.
Yeah, and there's obviously multiple ways to solve any of these scenarios. I mean, you can restrict what data goes in and out of a vector database. You can scan docs for the prompt injection, right? You can filter or reject anything that looks like suspicious, retrieved content. You can put the man in the middle or enforce a human in the loop, so to speak, for sensitive actions. There's a lot of different ways to kind of put these parts and pieces together. I'll go back to what I said before. I mean, first and foremost, it's kind of discovering and really seeing kind of at the execution level how these pieces and parts are actually operating in real time and in runtime. level. And then I think you called it out before. There's just certain things that you aren't going to see with any one of those solutions unless you can actually see at the process execution level, be it an exfiltration attempt, be it a any kind of privilege escalation. There's just a lot of different things that you need visibility to be able to kind of pull the whole picture together and see that full blast radius and impact. So good.
Yeah, that's
Go ahead.
yeah, the question's actually about the Cloud Ops agent one, which I think we're going to next. So
Yeah, we'll go to the Cloud Ops Agent one here. And again, this one's still fairly simple. I mean, this is the one that I think you called it out earlier. These can kind of start to multiply as agents create sub-agents, or as you look at orchestration type scenarios that would occur here. But in this particular path, you basically have your ops engineer. They're basically, their responsibility is to basically, use the agent, and they're going to clean up the unused S3 buckets. They're going to go get the information, from the model itself, and then basically it'll invoke a tool that's part of the S3 or part of the AWS component here. This is the one where, again, in this particular example, what you end up with is, the agent goes and lists basically the S3 buckets and identifies the data that it needs to operate on. But you'll pick up basically as you're working your way through this that there was privilege escalation. It's asking for a higher level role as it's working its way through this. Then you'll see that it's actually taking and making copies of those S3 buckets before it actually does the cleanup on them. And then you'll actually see that process execution where you're actually seeing it's trying to find an outbound place to actually send the information to some unknown or some other type of network component that exists on the outside of this. So it's an example where, to the user themselves, it's pretty simple instructions: go find and clean up the S3 bucket. But behind the scenes, we've got some infiltration that's occurred that's actually doing a lot of work behind the scenes that they wouldn't necessarily have the visibility to without actually kind of monitoring the process end to end via the runtime solution there. So you said there was a question.
yeah, and we can go through basically the question is at what point in this chain the SDK calls the STS escalation, the 312 megabyte egress, would my existing CNAP, DAST, or SCA actually catch it, or is the entire chain only visible at runtime? Um,
Yeah.
I mean, I feel comfortable. There's like theoretically pieces of this that would show up from like a posture vulnerability perspective. Like, so if you have, let's say you have a traditional CNAP, which usually has some like very light runtime, but we'll just ignore that for now and pretend you're like in pure agentless mode. Um, the only thing that it would show is, hey, this workload has the Anthropic SDK on it. And then it would tell you like which permissions or which IAM roles the EC2 instance has access to. Um, and then it might have an alert saying, because in this particular example, the agent escalated up to like an admin to do the run instances. But what's more concerning is the list buckets and get object like wouldn't raise any like massive identity red flags for just the copy data and exfil part. And so from like a identity alert perspective, you might have like a low to medium alert saying like, hey, permissions are kind of high on this workload, which everybody ignores. And then from an AI visibility standpoint, you would just know Anthropic is on this agent. Um, and SCA, same thing, right? Like it's just telling you, hey, this model exists on this thing. The DAST is interesting because DAST is expanding more into like AI red teaming and all of this. But in this example, this could be like a DevOps employee who's using this as a legitimate like cleanup and they got prompt injected, right? Like um, I think it was one of the Okta breaches was a DevOps home computer like gaming driver basically got injected and then they stole credentials to escalate off of that, where this could be a similar use case, right, where someone's either
Yeah.
copy pasting credentials or they're like telling it, or they're using like a MCP on their side to go inject additional commands to go run. And that's where basically no DAS tool is going to scan for those things. Or if they do, it's like AI red teaming of just trying to see if prompt injection works in general, but it's not actually scoped to your particular environment. And so no matter what, you only need the runtime. But I think what's really more important than needing the runtime is there's a lot of different types of runtime that are out there. And really, this is a great example of showing where you need both the network layer runtime detection to see the HTTP calls that are coming in, and then you need the cloud runtime to see the STS escalation chain, and then you need the application and process level runtimes to determine like what the agent is actually doing, what's making it so that it's actually choosing to go and execute these calls, that's executing follow-up calls. And what's really important here is not just saying the way that like a process execution would trigger an alert that's saying, um, hey, this, because this looks like normal activity. It's only when you have the context of this AI is calling these specific operations that you know that it's a malicious act. But yeah, anything you want to add on to that?
No, I think the last little bit that is what is kind of where I was going to go with it. It's a combination of things. I mean, the tool execution for the AWS SDK might or might not raise a high enough alert. The identity usage or the privilege escalation might or might not be something you pay attention to. And even the network exfiltration depends on where it's going, what it's targeting, things of that nature. But it's kind of seeing it kind of end to end and being able to correlate that information. And as you said, it's really there's a component which is the runtime information. There's a component which is actually the network kind of correlation as well. That is also being picked up with the runtime sensor as well. It's putting all those pieces together, seeing how it runs end to end, and then kind of calling out the okay, now we see the full picture, the full attack path, and we understand what's going on. So
Yeah, and I just think that's so important to call out with like CNAPs in general because you have like pure agentless and then you have like basic eBPF agents, but then there's a lot of depth that can go into an eBPF agent that's getting into the network layer, that's correlating with the cloud layer, that's getting visibility into the application and process layers. Like that's a different level of runtime than a lot of tools have.
yep, 100%. Well, good. Well, those are the three examples that I wanted to show. They just really lined up more with kind of this progressive, level of exposure that you would see with each of these types of AI agents. And again, we could have gone much, much deeper and made it much, much more complex, I think, on the agentic side. But I think that gets the point across fairly easily that it is that combination that we're talking about and that visibility of seeing it kind of end to end there. So good.
Yep, for sure. Um, Well, we'll hang on for a couple extra minutes. Please send any additional questions that you might have here as we're going. Um, but yeah, thank you so much, everyone, for your time. And hopefully, this was a helpful breaking apart of AI workload security that goes beyond just, AI is scary and how do we trust it and the sort of stuff, but actually trying to get into like real architectural examples of this stuff.
Yep. Great.
Cool. Well, thank you so much, everyone. I hope you have a good rest of the day.
Thank you.